Welcome to the Real Python Podcast. This is episode 253. Looking for a guide on getting started with Marimo notebooks? How do you build a reproducible notebook for sharing or create a dashboard with interactive UI elements? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's Weekly articles and projects. We cover a recent Real Python article by Ian Eyre about using Marimo notebooks. The tutorial covers installation, taking advantage of reactivity, building an interactive dashboard, and managing notebook's environment with sandboxing. The piece ends with an exploration of linear notebooks' limitations compared to Marimo. Christopher discusses an article about how to store the configurations for your Python scripts and projects. Whether you're managing resource handles to a database, deployment variables, or credentials to external services, you'll need a way to save and load the details into your Python project. The piece compares saving configurations in several common file formats or through environment variables. We also share several other articles and projects from the Python community, including a news roundup, the discourse between generative AI coding proponents and detractors, catching memory leaks with your test suite, Epigrams on programming, a command line tool to check packages on PyPI, and a collection of string, file, and object utilities. This episode is brought to you by 6 Feet Up, the Python and AI experts who solve hard software problems and rescue failing projects. When you're stuck, they save the day. Message 6 Feet Up on LinkedIn for a free consultation. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there.
All right, we got a chock-full episode today. We got a bunch of news items and a few announcements. And then we have a short discussion this week, something that I found interesting in my conversation that I had with Rodrigo recently. I thought I'd bring it up. And then, of course, a couple projects. You ready to dig in?
Yeah. I think the people who cause news to happen are anticipating the summer and trying to get it all out before the lull starts.
And before the big vacations?
Exactly. It's going to slow down, and then I'm going to be complaining that I don't have enough to link to in PyCoders. But for now,
Yeah, totally.
Let's start with 2 release announcements. First, as we predicted last show, Python 3.14 Beta 2 has come out. And second, there was a security release for Django giving us 5.2.2, 5.1.10, and 4.2.22. It's a low severity issue with logging injection, which really only would affect you if both your tool was broken and the log consumption tool is broken. So it's not one to worry about too much. From releases to conference announcements, PyBay 2025, great regional conference in San Francisco. This year it's happening on October 18th. The call for proposals just closed, so the schedule should be coming out shortly. And the other conference is PyCon Netherlands, which is October 16th. So you probably can't go to both. That would be a heck of a flight. They've just issued their call for proposals. It's open until August 1st. Regional conferences, like we've said before, are great places to do your first talk. So if that's something that's on your bucket list, both of these are things you should be looking at.
Yeah, cool.
Part of the reason my news list is long this week is I'm stuffing things in that aren't quite news.
Me too.
The first sort of news thing is a follow-up to episode 251, where we talked about T-strings, which are coming out in Python 3.14. Over on the Django Forum, there's a conversation going on how Django might take advantage of T-strings and where they might get used. One of the examples is inside the format HTML utility call. So if you're curious about how this new feature might actually impact libraries you're going to be playing with, this is a good little read of a lot of the core guys going, hey, we could do this, we could do that. So that's kind of neat. And the other sort of news We linked to a Reddit conversation in PyCoders last week that I thought might be useful to folks. The title is Ruff Users. What rules are you using and what are you ignoring? So if you use Ruff and you want to see what configs different people use, this is worth a gander.
Yeah. In my conversation with Charlie Mars, we dug in pretty deep about the idea of having sort of rule sets and the idea of that being something that you should definitely look into as far as customizing them. And so it's probably nice to have some additional recipes to look at. I have a quick, it's sort of an announcement, but it's also kind of an interesting experience here that happened. We have a new author on Real Python, Amanda N.A. Adoye. Her first tutorial about nested loops published recently, so congratulations. And she decided to write about her experience working through our editorial process and working with the team. It's kind of a cool behind-the-scenes look. I mentioned it as we have questions often about real Python processes. We had that experience from the audience at DjangoCon, which was really fun. So if you're interested in writing for real Python, this might be an interesting thing to have a look at. Congratulations and thanks, Amanda. I think that takes us right into topics this week. I've been on social media maybe a bit too much lately. Who could guess why?
And there's your first problem.
And I kept noticing some trends happening in the AI conversation and people kind of being, I don't know, maybe a little hurt by some of the conversation that's been happening. But I wanted to kind of get an idea of like what this conversation's about at a little bit of a deeper level. And luckily it moved pretty quickly off of the social media things into blogs and longer posts and stuff like that, and some really long posts. And it's sort of an intense reaction from the more pro AI developers, and they're rather upset that their tools and what they're doing and the announcements are being criticized and crapped on. And the critics are being referred to as the anti-GenAI crowd. And then the proponents in this current climate are sometimes referred to as the anti-GenAI crowd. It's actually a bit funny that each side has a certain amount of professional civility for the other side. Each piece I see mentions people I have respect for, and sometimes that's in past tense. Lots of fallacy throwing, straw men being built and burned, and all kinds of fun stuff happening. I was only going to mention one of these pieces, but it kind of became a flood as I started to look on it. And right as Chris was sharing one with me, I was like, yep, I just started looking at that one myself. So the first one that I took note of was by Thomas Tacek. It's titled, very friendly, My AI Skeptic Friends Are All Nuts, which is on his The Fly blog. And as the title suggests, this one has a little more disdain than some of the others. What Thomas has started to experience in the last 3 or 4 months is a real change in how LLM systems themselves are working and writing and optimizing code. And he feels like he's reached this new level of a new sort of point of productivity. To me, again, a lot of these developments are in a very unique, special space. And so I'll include a kind of a long quote from his piece. People coding with LLMs today use agents. Agents get to poke around your code base on their own. They author files directly. They run tools. They compile code, run tests, and iterate on the results. They also pull in arbitrary code from the tree or from other trees online into their context windows, run standard Unix tools to navigate the tree and extract information, interact with Git, run existing tooling like linters, formatters, and model checkers, and make essentially arbitrary tool calls that you can set up through MCP. So the code in an agent that actually does stuff with code is not itself AI. This should reassure you it's surprisingly simple systems code wired to ground truth about programming, in a sense, the way that a makefile is. You could write an effective coding agent in a weekend. So this is different even than some of the conversations I had with Simon Willison kind of at the beginning of the year about how he would be working in chat environments and trying things out and having a conversation about refactoring and so forth. But mostly in those environments, he was like copying and pasting the code out. This is like more working inside of the tools themselves and then setting up these agents to do a lot of this sort of busy work. This piece, like I said, has a lot of disdain in it. There's like a whole bunch of headings with sections like, but hallucination, but the code is crappy, like that of a junior developer, but it's bad at Rust, but the craft, but it'll never be AGI, but they take our jobs. but the plagiarism. And so there's a lot of this idea that, yes, there are these complaints. And again, there's some reasoning behind that. It's not all completely just sloughed off. But right at the end of all of it is, I'm tired of hearing about it. So I just think it's interesting to watch this conversation. And then that's where the one I mentioned before that Chris was sharing with me, Cliff Lefkowitz, is a very well-known Python dev, created the Twisted framework. He's a known lecturer and has been around, kind of an all-around Python luminary for a long time. So he enters the chat and then exits the chat, if you will. This is a very long piece. It's titled, "I think I'm done thinking about genAI for now." And I think he felt pushed into this conversation by the anti people. He says in the piece about, how this genAI discourse is sort of bad, wishing for the skeptics to be more pointed and accurate in their critiques. And general arguments are a lot of the bad things mentioned in the other piece, which in many cases are real and concerning, and sort of this pushback between it. Glyph's piece is big. It's, I think, just over 10,000 words. It's really well documented, lots of footnotes and links to the references. And he admits to not having a good experience using these tools himself, and pretty much feels that they're abhorrent and damaging to the industry generally. Lots of general concerns across the whole piece. One of the persons that I saw complaining the most on the social media side was Armin Ronacher, who I've had on the show before, creator of Flask. His piece is titled "AI Changes Everything." He's very pleased about how Claude Code, that's the name of the tool, has changed things for him. And he states that's kind of over the past 2 months. Quote from his is, "Do I program any faster? Not really. But I feel like I've gained 30% more time in my day because the machine is doing the work. I alternate between giving it instructions, reading a book, and reviewing the changes. If you would have told me just 6 months ago that I'd prefer being an engineer lead to a virtual programmer intern over hitting the keys myself, I would not have believed it." And I think that's kind of the key thing that's happening here, is these people are getting sort of assistance through this tool, this sort of agentic thing that's happening behind the scenes that's doing some busy work. Armin went through the extra effort, and I put that in scare quotes, to compare his piece with Glyph's. I'll include a link to every one of these things, but he did this AI blog comparison using ChatGPT and prompted it with, "They both talk about the same thing, but have vastly different opinions. Can you analyze them and compare them? And what do these posts say about their authors?" I don't know if I agree with the generalizations that ChatGPT made about the authors. Anyway, but I'll include a link. You can look at it. Again, the conversation's changed over the last months. A lot of people keep throwing out 6 months, but I really feel like it's more like 2, 3, 4 months, where these tools are coming up and the tooling is being created for the developers kind of directly. And I don't have the experience of working within an organization. That's why I ask Chris all these questions all the time, where you have like junior devs and you have this idea of reviewing code of others and bringing it in. And so I can see a more seasoned developer having both of these takes and having opinions on, like, what is this doing to the industry, but also like, what is this doing for the industry? Like excitement. And at the same time, would a new developer get all these advantages if they don't understand like how the things used to work? What is this replacing and how should this be done? So I kind of wonder about that. How do they develop that type of experience? And will that be part of the process of maturation in the software field? Will that be lost? I don't know. I'm right in the middle, kind of been for a while. I haven't lived through the AI winters of yore. And I also have I did, but I wasn't a programmer at the time. And I also have a strong distaste for the majority of the players in this game. And I'm talking about the people at the higher level, the VCs, the oligarchs, the massive corporations, the hucksters, the scammers, all the people that are out there that are doing the current get rich quick stuff with it. And it's hard to leave that distaste in my mouth because that's what's being shared with me more often. I've personally spoken to individuals and asked them why they used genAI for certain things, and I don't know if it's a benefit. What I mean by that are more of the artistic side. Like I've asked people that are, kind of Python influencers, like, why are you using AI art? And then they were like, yeah, why am I? And I thought that was interesting. And a few of them changed or started to think about why they were doing that. I'm starting to see a little decline on that, which is good in my opinion. I really don't like how that stuff looks. I truly despise the video generators and music generators and all that stuff. And I know that doesn't have much to do with programming, but it's all, unfortunately, part of the conversation in a weird way. And I feel like it's polluting the pool of music and movies and TV and writing and stuff like that. I worry about that. It's an interesting time. I thought I'd share some of this and provide you some reading material if you want to dig into the conversation yourself. And I know Chris was going to say that he didn't really have much of an opinion on this.
I find it's hard. It is such a broad-ranging topic.
Yeah.
And I think this is where some of the social media angst comes from, right? Like Armin's complained that he says something positive and then everyone accuses him of things.
Right.
And that's the internet being the internet, right?
Yeah.
There's so much hype in this that there's going to be backlash to the hype. And so if you have a positive experience and you speak about it, the people who are experiencing the backlash part of it will pile on without actually necessarily reading what you said, right? So it's messy. And, for me, this stuff is always, it's a tool.
Yeah.
For every article I find where a programmer says this helps me, there's another article I find who says it doesn't. It's challenging even without the tool. Measuring programmers' productivity is very, very difficult. Programmers measuring their own productivity is almost nonsensical. I had a little bit of I had a little data file I had to muck with last week, and I spent about an hour writing a little script so that it would massage the output to what I wanted it to be. It probably would have taken me 10 minutes with copy and paste in Excel to cause the same result. Now, if I run this script 6 more times, I will have paid that off.
Investment.
But I didn't want to copy and paste it because that's boring and messy, and I can write a program and solve this problem, right?
Right.
So, if you're talking about my productivity, I'm probably never going to get an ROI on that ever. I probably will. I might run it once or twice more, but maybe not 6 or 7. So we're just bad at this kind of stuff.
Right.
And then you get management saying you shalt because, we think it's going to improve productivity, therefore you must, which of course is going to cause backlash as well.
Yeah.
And there's some underlying pieces here that I'm not clear on what's going to happen because VC money muddies the waters, right?
Yeah.
When Uber first started in my city, it was illegal and about half the price of a cab. It's now legal, and it's the only thing out there besides the cabs, and the prices are about the same as the cabs. And their entire pitch at the beginning was, we're cheaper because app and gig economy and whatever. And it turns out they were cheaper because they were flooding the market, and they could do that because of VC money. Right. So, the article you started with here, he was talking about the fact that this costs him $20 a month. Well, once we figure out what is and isn't profitable here, that may still happen, and maybe it is worth, there's $20 of value there for you. Good for you. The problem is these things are terribly expensive on the back end. So once the VC money dries up, the pricing on it may be completely different. And so what's useful and valuable now might not be useful and valuable, 2 years from now.
Yeah.
So it's a messy thing. And that's without getting into things like the environmental impact of,
right. The other costs. Yeah.
So there's a whole bunch of externalities here. And there are societal parts that are hard to differentiate, right? Like, hey, when senior developers say this is helping me, I have no qualms. If it's helping you, great. When one of my students says I did this, well, okay, what you're doing is not learning. And the whole purpose of the exercise was to learn.
Yeah.
And, people are going to do that. I don't think of it as cheating. I don't care. If you're going to do it, you're going to do it. But if you're using this tool as a crutch, you're never going to learn to sprint because you're always on the crutch, right? So, and it's so hard to separate one of these things from the other. And it's a morass.
Yeah. I mean, as a teacher, that's definitely something I see a lot. I know the goofy arguments about but calculators, and it's like, okay, sure.
Yeah,
it's all these other kind of stuff. It's not the same thing.
Well, even with calculators, you have to teach kids how to estimate so that they can use calculators better, so that they know if they hit the button wrong.
Right.
Right. So there's still a learning curve there with the new tools. One of my nephews bragged about finishing this coding problem he had in a high school course in 15 minutes. And, it took my brother 3 hours. I'm like, well, how did you do that? Well, I stuck it in ChatGPT. Well, that's like bragging I finished it because my buddy gave me the assignment. Like, you haven't actually learned anything. Now, if you don't want to learn anything and it gets you your little check mark, I'm not going to judge, whatever. But if the purpose of it is, the one article was talking about, learning how to build tables, and ChatGPT is basically IKEA furniture. And if what you need is a table, IKEA may be the right answer.
Right.
If what you're trying to do is to be a carpenter, then assembling IKEA isn't going to teach that to you in any way or form, right? So there you go. There's your soundbite. ChatGPT is the IKEA of programming.
Yeah. I don't know if you've ever tried to move with that type of furniture and taking it apart and then try to reassemble it yet again.
It doesn't tend to last. Yeah, there's that problem too. Yes.
Yeah. Yeah. That's a big difference there. And that's what I wonder about with the code too, or all these other kind of weird creations, like I guess built to last could be put in there a few different ways.
I also wonder about the psychology of it as well. So I wonder whether folks who get, different people react differently to things like false positives and false negatives, right? And so if a false negative doesn't bother you as much, maybe you're willing to sort of work through the hallucination's fine, you just learn to deal with it. Whereas if you find that very, very frustrating, then, you're going to hit a break soon, right? Like Firefox has this issue where if it expects an update to be happening every once in a while, its JavaScript engine gets a little flaky, and not enough that you notice it. But like, I have burnt hours where I thought I was debugging a bug, and what was needed was a browser restart. Mm-hmm. And like, that pisses me off to no end, right? Those are hours of my life I'm never going to get back. So an LLM saying there's a bug here and there isn't one, and me chasing that would be like a hard stop for me, right? I'd be, screw this, I'll never use this tool again. Right. But someone else went, oh, that's neat, why did it do that? They might take a different approach.
Yeah. The trust thing is a big problem with me. Yeah. And I agree with the whole, being a teacher, like, how are you going to learn to do this stuff in the future? And it's just, it's messy. I'm so surprised at like how upset people are by having any complaints. It's like, well, you're on the internet.
Well, and some of the folks who are getting yelled at are folks who've deeply invested in this, right? And
yes, feelings are being hurt.
You get this all the time. It's like, I was promoting my book 5-6 months ago, and I was on a non-Python podcast doing it. And, and the first thing somebody said was Python's slow. And it's like, really? We're having this conversation, right?
Right. And the other one I've heard recently was like, this is not a programming language.
Python's not but you get defensive, right? Like, you spend hours and hours a day, months and years deeply invested in it, and some random person comes along and goes, your decision was bad.
Right.
And it's hard not to react to that, right?
Exactly.
It's very hard not to react to that. So don't feed the trolls.
Yeah. Don't feed them. It's time to shine a spotlight on another Real Python video course. Software is never static. Bugs need to be fixed, features need to be added, and security demands regular updates. Robust DevOps systems are crucial for managing an evolving codebase, and that's where GitHub Actions shine. And this course is titled Python Continuous Integration and Deployment Using GitHub Actions, and it's based on a tutorial written by Ricky White. And in the video course, Philip Exeni will take you through how to use GitHub Actions and workflows, setting up automation of tasks like linting, testing, and deployment for a Python project, how to specify which Python version should be used for running those tasks. You'll start with a basic workflow and develop the scaffolding and techniques that you can use with your own projects. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. What's your first one you got here?
I've got an article called Configuration of Python Applications. It's by Robert Rode. When you're writing software, you often need to change its behavior based on some set of inputs. You could use command line flags, but if there's a lot or you're trying to do them a lot, then maybe a config file is a better choice. There are multiple ways of doing this in Python, which kind of goes against the Zen, but let's ignore that. Robert's article starts off by explaining when you might want to use configuration, why you might use it over, say, hard-coded values in your code. And then once he's done that, moves on sort of the heart, which is running through the different kinds of formats that are supported by Python. The first format is the INI file, sometimes known as the INI. Not sure if this originally came from Windows, but it definitely was the de facto configuration mechanism for Microsoft for a long time. So most people think of them as Windows INI files. These are a text-based format that defines key value pairs along with the ability to group the pairs into sections. The Python standard library's config parser module actually has a mechanism for reading these kinds of files. You construct a parser object, call its read method, and then you can use that object as a nested dictionary, with the outer layer being the sections and the inner layer being those key value pairs inside of the section. The second format covered in the article is JSON. This has become popular, particularly if you need to send your config to some other machine or another programming language, because it's often interoperable. And Python has a JSON module in the standard library that allows you to read and write these files. And like with the config parser, you end up sort of doing a dictionaries, or with JSON, you can also get a list of dictionaries kind of thing going on. One of the newer kids on the block is TOML. This is a cross-language text format that's similar to the INI format, but has more features, handling specific data types, lists, dictionaries, and more. TOML parsing got added to Python 3.11, and there's also a third-party library that can handle it if you're using something older than that. The fourth format that he covers is YAML. The less said about that, the better. Sorry, that's me getting up on my soapbox.
Yeah.
This is a very, very flexible standard, and that flexibility might mean you might bend over backwards and chew on your own behind. YAML isn't part of the standard library, but the PyYAML library is out there, and it's very, very common. Plenty are using it. If all of that isn't enough, there are also non-file-based options as well, like putting your configuration in shell environment variables. The article runs through how to do that, as well as libraries like the Pydantic settings library, which allows you to build objects that are validatable, that are based on the environment variables, which means you can do default values and other stuff like that. After all of that, the article then goes on to talk about when you should load these kinds of settings, how you might mock them when you're doing testing, and all that kind of good stuff. Personally, for local scripts, I tend to default to TOML myself now, but if your domain favors one of the other choices, you should use what fits best for your domain. Robert's article has code examples all the way through.
Yeah.
So if you want to see how all these little bits work and when to choose what, then it'd be worth checking out.
Yeah, this is great. I wonder about this because I've seen lots of sort of step-by-step projects where it's a mix of these different things, depending on what the author was interested in. And so I kind of wonder about that. Like yourself, are there certain situations where I'm more likely to use the .env type stuff versus having a configuration file?
So the environment variable stuff is very common in Docker containers or virtual machines, because you want to be able to configure, you want to upload a set of files and then not have to muck with the files, but you want external control. And most virtual machines will allow you to say from the outside, when you boot this virtual machine, set these values, or when you start this container, set these values. So that's a common process there. Likewise, YAML is really, really common in the DevOps world. It gets used to spec out things like AWS servers and that kind of thing. So if you're working there, then YAML would be your better choice. And this is why I say, if it's for me and my script, I go TOML. It's flexible. It solves the problems I want to solve. But if you're trying to solve it in those other worlds, then that's a square peg and you go look for a round hole or whatever I'm trying to say there.
Right. Yeah. And I like that. It's a nice survey across all of them. So it might be a good reference for later, depending on, I'm moving into this thing and they're suggesting using this. And so you can kind of have a nice tour of it.
Yeah. And it kind of highlights the fact that batteries included and there is one way of doing things is a contradiction in terms.
Yeah, definitely. All right. Well, I've been wanting to have a guide. I mentioned this about a couple of my interviews. The one with Charlie Marsh, I was wanting to have a guide for UV, and I mentioned that in our last conversation together. And this week, I've got one about Marimo. This is by Ian Eyre. We've featured Ian multiple times lately, and he's written this new tutorial. I don't want to go step by step on this one, so I'll kind of try to cover the highlights and do my best to sort of summarize what's in it. It's not a step-by-step project, but it is very step-by-step in the sense that you get to really build these things and play with them. Lots of examples. A few of these things where he'll turn around and say, okay, go try this as an experiment and come back. And so I like that sort of challenges and stuff like that. We feature this thing on a lot of our articles where there's sort of like a heading with bullets to sort of give you the gist of what this whole article is. And I'm just going to read them because I feel like it does a great job of covering a lot of the points. Marimo notebooks automatically update dependent cells, ensuring consistent results across your work. Reactivity allows Marimo to determine the correct running order of cells using a DAG, a directed acyclic graph. Sandboxing in Marimo creates isolated environments for notebooks, preventing package conflicts and ensuring reproducibility. You can add interactivity to Marimo notebooks with UI elements like sliders and radio buttons. And traditional linear notebooks have inherent flaws such as hidden state issues. And Marimo addresses this with its reactive design. So I talked a lot about these in my conversation with Akshay Agrawal, the creator. As far as the initial steps getting you into this, you can install Marimo with pip. So Ian takes you through that, takes you through creating a notebook, touring the interface, the cells, all the buttons and their individual functionality. It's a little different than a Jupyter notebook. And so this is going to give you an idea of like, okay, well, what's different in the UI here? And then he gets right into working with Markdown inside of Marimo. And I've never used this before, but have you ever used $ inside of Markdown to sort of do the formatting for mathematical equations? Have you ever used that before?
No, I didn't know that was there. Is that pure Markdown or is it a variation?
I don't know. I got to figure that one out because I thought that was kind of cool because it definitely showed, what you would normally see like in a textbook be formatted for mathematical equations and things like that. It kind of provides these nice aesthetics that you can do in there as far as notebooky stuff. You get to practice with the reactivity stuff that I mentioned earlier, changing values, updates happening across the entire notebook, no matter if it's different cells and what order they're in. Ian actually digs into the idea of reactivity and how it supports the reproducibility. Very early on in the show, I talked about Jupyter notebooks, and that is one of the biggest problems with them is the idea of state. With this directed acyclic graph, there's actually a button inside of Marimo that will actually show you how the cells depend on each other and how they flow. It's literally a button that's, if you highlight it, it'll say explore dependencies, and it can be laid out vertically or horizontally as a tree. And you get to see how each one connects to each other, which I thought was interesting. I didn't know that was a feature in there. And you can then see the run order with the lines connecting the different cells. One thing that I haven't seen often, which I like, is that he gets into the interactive part of it. And there's a lot of UI elements that are built into the library. So like Marimo UI.slider, UI.radio button, or UI.text. And then you build a thing with creating a basic dashboard and with multiple variables and a graph. And then that's where he kind of throws it to you to do some challenge exercises and for you to practice some of your new skills. And then he gets into this area where I've had this back and forth talking about some of the features of how these two things interact, meaning UV and Marimo. He talks about managing notebook environments with sandboxing. And then one thing it will need in that case is you will need UV because it's using that as kind of the package manager underneath that. And then he explores exporting notebooks as an HTML file. Here's a final section that's interesting, again, kind of comparing the two platforms. Like he calls them linear notebooks because I guess Jupyter's not the only version of that. There's a few other tools that are out there. This section is called linear notebooks don't quite cut it anymore. And again, one of the main issues there is the state. If you've run a cell in your session, having things going there, and then you delete it, you might think to yourself, okay, well, that stuff's out of memory now. But it actually isn't. It's been run. It's now in memory. And it's something you have to kind of think about. Or if you run cells in different order, you'll get completely different results depending on things. And so that's kind of one of these things that's very unique about this and kind of makes for, again, consistency, reproducibility, and other advantages. So thanks, Ian, for this great tour of Marimo.
I was listening to actually on Talk Python the other day, and he was quoting something where somebody went through GitHub, found all the Jupyter notebooks basically, and it was like 40% of them were not reproducible or something like that, but without the actual statistic.
Yeah. It's old JetBrains.
Yeah.
I think it was them, but they had gone through and done a whole survey. This is almost like 4 years ago, and they just tried to run them all. And they just don't run. Yeah.
Yeah, and the other thing was the that $ thing is part of GitHub. They've got their own version of Markdown that has a bunch of extra meta stuff in it. So,
oh, cool.
They've become sort of the de facto standard because that's what everyone uses Markdown for anyways, is for the README. But
right, often, yeah.
Markdown is kind of like USB-C. Like it, there's Markdown and then there's Markdown. But anyways,
right.
All right.
Yeah. Are you dealing with a Python project that's gone off the rails? Or an AI initiative that's completely stuck? 6 Feet Up specializes in exactly these situations. With deep Python and AI expertise, they rescue failing projects, deliver enterprise-grade solutions, and get you to market faster. They've automated healthcare pipelines for hospitals, helped NASA explore Pluto, built severe weather prediction tools, and used AI to connect farmers with critical crop data. When your project is in trouble, 6 Feet Up gets you back on track. Learn more at 6feetup.com and message 6 Feet Up on LinkedIn for a free consultation.
My next one's called Catching Memory Leaks with Your Test Suite, and it's by Itamar Turner-Trauring, who we've featured 6 times before on the show. So that's pretty impressive. That's particularly considering he's not a real Python person. So he's almost hitting Leo Donis levels there without any even association. So to start with, let's define a memory leak. Well-behaved program needs to allocate memory for storage, and when it no longer needs that chunk of storage, it should free it up. For long-running programs, if the allocation and free calls don't match, then you're going to consume more and more memory over time, and eventually you'll run out, and your operating system will crash the program. In modern operating systems that use disk as secondary memory, you'll also possibly see drastic slowdowns first because reading memory in from being paged out to disk, that all slows your program down. Some lower level programming languages like C make the programmer responsible for freeing memory. This kind of makes sense as the programmer is the one who says, I needed it. So this is when I don't need it anymore. That is kind of logical. It's problematic though. Say you've got a function that allocates some memory and returns that object. Well, then something besides that function now is responsible for freeing it. And heaven help you if you free something that has already been freed, bad things ensue. So because this is all error prone, higher level languages try to help you with it by having things like garbage collectors. In Python, you don't have to explicitly free something. The interpreter figures out when something goes out of scope and then frees it for you. But that doesn't mean you can't have a memory leak in Python. The key part of that last bit was when the object goes out of scope. So say you have a module level list that you've been sticking things into. If you never clean that list up and you've never removed the objects out of it that you no longer need, it's going to grow indefinitely. And because it's still within scope, it's never going to get garbage collected. You can get away with this with small programs, particularly if they run for short periods of time, because everything gets released when the program exits. For longer running programs or ones that use a lot of memory, you've got to be careful about this. So there are profilers out there that can help with it. Itamar's article mentions 3 of them: Memray, Fill, and Sciagraph. Each of these have their own pros and cons. The heart of the article really is a different approach, which is how can you spot some of these kinds of problems in your unit tests? The approach he outlines has some conditions. First, you need a test suite with good coverage. If you're not running most of your code, you're not going to catch these kinds of problems. Second, the leak needs to be fairly consistent. The kind that pops up because of some rare corner case might not get triggered in your tests. And third, the leak's got to be large enough. There's always a little bit of sort of variability when things get, because there's other things getting allocated, so your numbers are never going to be quite consistent. So as a result, this tends to only catch the bigger problems. This means this approach won't catch everything, but it will catch your more problematic cases. So that's not like it's not worth attempting. And the process essentially goes like this. Before you run your test, you check out how much memory there is. Then you run the test, and then you check how much memory there is. And if the numbers don't match within a little threshold, you might have a leak. So the article talks about how to use the trace malloc module to track memory usage in Python. There's a caveat here. There are other ways of allocating memory in Python, usually with third-party libraries that won't get triggered, that you won't be able to trace with trace malloc. So for example, if you're debugging polars, this won't help. Itamar demonstrates a PyTest fixture that includes this leak detection feature. A couple things I want to highlight in it. Inside the fixture, he forces the garbage collector to run. This is important as that process isn't guaranteed to run in order with your tests. So if you aren't explicit about triggering it, it's possible that the memory just won't have been collected yet. And then it looks like you've got a leak when you don't actually have a leak. And then the other thing, like I said, there's a bit of a threshold here. Itamar set his to about 10 kilobytes. So anything that looks like there's more than that wiggle room, he triggers as a failure. And there's a comment in the code that essentially says, you might want to adjust this number depending on what you're testing. The article goes on to talk about what can be done if you find a memory leak, as well as gives you some hints about other kinds of resource leaks that you might catch with a similar approach. So like always, Itamar writes some good stuff, and this is well worth the read.
Yeah, it's making me think about, I talked to Itamar directly about Phil, his tool, and then I had Pablo on the show. We talked a little bit about memory, and then I had another guest on, again, if you're interested in this profiling space, and tools that maybe can go beyond just the Python stuff. Emery Berger came on the show on episode 172, and we talked about kind of measuring Python performance with his tool called scaling, and it goes across all the different tools. So you do have something that is calling out and doing other processes that are outside the Python world, which is really interesting. And what's nice about almost all these tools is they've gotten more graphical, really kind of show you what's happening and so forth. So we've talked about performance a handful of times on the show, and there's some resources. I'll include some links that you can do some more research if you want to check it out.
My first professional coding jobs were in C, so this just gave me PTSD.
PTSD.
Yes.
All right. So I have like kind of a short discussion thing. This is something that came up when I had Rodrigo on the show. Well, he had shared one of these epigrams with me, but he talked about Alan Perlis. Alan J. Perlis was an American computer scientist and professor at Purdue University and Carnegie Mellon and Yale. He won the Turing Award, and in 1982, he wrote an article titled Epigrams on Programming, and this was for the Association of Computer Machinery's SIGPlan journal, and 1982 was pre-internet. So I did find a web archive of something else that was out there, and so I'll include it. There's, 130 something? It's quite the list. But they're kind of like, literally 130. They're sort of thoughts on programming. You have to think a little bit about 1982 and what computers were like then, and how many of them were, literally like personal computers, and predates phones and all these other things that are literally computers now in our hands. But the one that Rodrigo discussed with me was get into a rut early. This is number 10. Get into a rut early, do the same process the same way, accumulate idioms, standardize. The only difference between Shakespeare and you was the size of his idiom list, not the size of his vocabulary. So we talked about that idea of like, you can learn the vocabulary and the syntax of Python, but really you have to move into this new level of like, how do I combine those things together? And how do I create my own programming idioms that make sense? These ways of combining the code together, and then you end up using those across your whole programming career, which I think is interesting. And I think that's still universal. Some of these are not so universal. Some of these are a little more based around earlier programs, lots of mentions of Fortran. And I like this number 39. This is still kind of true, even though graphics have changed a lot for us. A picture is worth 10,000 words, but only those to describe the picture. Hardly any set of 10,000 words can be adequately described with pictures. So the reverse is not true. Yeah. So you had a couple you wanted to mention?
Yeah, I liked every program is part of some other program and rarely fits.
Yeah.
Yeah, things are never in isolation. And kind of
Yeah.
going with that was every program has at least two purposes, the one for which it was written and another for which it wasn't.
That's so true.
And one of the reasons I kind of liked this one was because some of the code I am proudest of is the code where like a decade later, I'm talking to somebody like, oh, they're still using that?
Yeah.
And you're using it for what?
Yeah.
And the fact that they're able to sort of twist it and play with it and get value out of it without it falling over, even though they're not doing what its original purpose, that to me is like a sign of that sort of stability kind of value thing, right? Like at its heart, as programmers, we're trying to solve problems, and if we're solving them for other people and it gets to keep solving them, then there's a little bit of a gold star, shiny, hey, I did that.
Yeah. That's why I like this one. Number 58 was fools ignore complexity, pragmatists suffer it, some can avoid it, geniuses remove it. Yeah, which I think is pretty true. So you had a couple more?
Yeah, if you have a procedure with 10 parameters, you probably missed some.
Right. Number 61 is in programming, as in everything else, to be in error is to be reborn. And I think that's something that's gotten better in Python. We talk about just the ways that errors are now being shown to you in a much better light and like truly pointing out like, okay, well, where is this happening and so forth, and going a little bit beyond just the stack trace that we were dealing with a few years ago. So I like that. What's your next one?
Well, the last one I have is probably a good one to end on. So if we're
okay, I have one that I just saw that I thought was funny, kind of related to what you were saying, and I hope it's not the same one as number 17. If a listener nods his head when you're explaining your program, wake him up. So I think we've all experienced a little bit of that, talking to other loved ones about our stuff.
Yes, that's dinner every day at my table. And at risk of bringing us back to possibly that earlier conversation happening,
evergreen.
It's easier to write an incorrect program than to understand a correct one.
Yeah, very true. Anyway, so these are interesting. They kind of are like fun to ponder on, and maybe we'll come back here sometime and think about it a little bit more.
Programming equivalent of fortune cookies, yes.
Yeah, exactly. Crack open at your next meetup. Cool. I think that takes us into projects. My project is kind of a small one. I really like it because it's a good example of like how you can build out a kind of a complete command line interface in Python, have it access a well-designed API. And so I think it's a good case study. People have always asked, where can I look at other code to get an idea of like how I should structure stuff, things like that. This project is named whatsonpypi, altogether, no spaces. Subtitle is Check PyPI from the command line, and it's by Vijesh Rajendraprasad, and it's designed to get package information from PyPI. It uses requests to access the PyPI REST API and then parses the JSON and displays it. There is a rich variant of the tool using the rich package. So if you want a more colorful terminal output, but it's rather straightforward. In the credits, he mentions Click, which is the framework that's being used throughout it, which is a nice framework. Another callback to Armin, I think, there. And as that's the main CLI tool that's being used. He also notes that he was inspired by a lot of Simon Willison's work, and we've mentioned that before. So there's like a link to Simon's GitHub there. He makes lots of these kind of fun CLI tools also. I don't know if he specifically has a What's on PyPI one. So this is another way that you could search the information and the dependencies sort of graph of things happening on PyPI. What's your project?
I've got something called strif by Joshua Levy. It's a catch-all string and file utility library with over 30 functions in it. I read something from the README. The goal is to complement the standard library, filling in a few gaps. So he divides the library up into a few subsets. The first is atomic file operations. So if you're dealing with concurrency, atomic operations are key to avoiding race conditions and deadlocks. The operations in this part of the library allow you to copy and write files in a thread-safe way. There's also a variant on rlock, which we spoke about in episode 251. Again, more thread safety stuff. There's a group of utilities for abbreviations and string quoting. These can be handy if you're writing things to logs. There's some functions for doing hashes on strings and files, using several different hash string formats and a series of functions for manipulating multiple strings at once. So the library's got no dependencies, which makes it nice and clean. It's less than 1,000 lines of code, so small little memory footprint, kind of a callback. At the end of the project's README, Joshua also points you at other libraries that do similar things, which is always nice. Some good stuff in here, the classic sort of I need it myself and kept rewriting it kind of library that, you can take advantage of when someone else has that problem and maybe save you some code. So
yeah,
take a look.
Great. Well, thanks for bringing all these PyCoders weekly articles and projects this week. I don't think we've mentioned this in a little while, but again, if you want to make submissions for maybe you have projects or you've written some stuff or you want to share some resources with us, we have a submission form and I'll include a link in the show notes. I don't know if there's anything else I need to mention with that, Chris.
No, and in the summer's coming, that's the dry period. You're much more likely to get included, so take advantage of it.
Yeah, please send some stuff. Well, thanks again, Chris. Good talking to you.
Cheers.
Hey, just a note. The genAI conversation continued through the time of editing the show, so I included even more links to the further conversation within the show notes. And by the way, if you aren't checking out our thorough show notes on realpython.com/podcast or in your podcast player, you're really missing out on additional great resources that I've gathered for you, which will further the context of the conversation on all the topics that we covered this week. Thanks again to 6 Feet Up, the Python and AI experts you call when your project is in crisis. They solve the hard problems and rescue failing initiatives. Learn more at 6feetup.com and message 6 Feet Up on LinkedIn for a free consultation. I want to thank Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.